Hello, everybody, and welcome to today's webinar presentation, Securing Web Applications and APIs with Confidence, brought to you by Palo Alto. I'd like to introduce you to our presenters, Ori Sagel and Elad Schuster. Ori is a world-renowned expert and veteran in application security with 20-plus years of experience. Ori joined Palo Alto Networks through the acquisition of PureSec, where he was a CTO and co-founder. Ori holds numerous patents in the field of application security. Ori serves as an officer of Web Application Security Consortium and is a former CSA Israel chapter board member and a former WASP Israel board member. Elad is the product line manager for Web Application and API Security, Palo Alto's cloud-native application firewall. With over 10 years of experience as a cybersecurity practitioner, Elad has presented his work in leading security conferences, such as Black Hat and OWASP's AppSec USA in Europe. Prior to joining Palo Alto Networks, Elad led a team of security researchers at Akamai, exploring new trends and emerging threats in the world of web application security. And with that, I'll hand it over to Palo Alto.
Thank you. Good day, everyone. We're very glad to have you here to hear us talking about cloud-native web application security, how to secure web applications and APIs with confidence. Let's start. Next slide, please. Great. So let's start by sort of framing the discussion for today. We're going to talk about these four main topics: the emerging challenges related to securing web applications and APIs in the cloud-native world, Palo Alto's unique approach to web app and API security. We'll see some use cases, and then we'll see hands-on, very cool hands-on demo. So to begin with, the domain of web application development has really changed dramatically in the past few years. And this happened through the introduction of modern cloud-native application development that by itself introduced several key changes, especially around the software development lifecycle, the SDLC, and how it's connected to application security. And so we will discuss the challenges today. We'll present, as I mentioned, our cutting edge and very unique approach to securing cloud-native web apps and APIs as part of the web app and API security module of Prisma Cloud. We will talk about some of the use cases and the capabilities within our solution and see a very cool demo that Elad prepared for you today, showing how attackers exploit the latest Log4j vulnerability, which I'm sure all of you heard about, as well as how you can obviously protect yourself against such attacks with the web app and API security module with great ease, if I may add. Next slide. Okay, so let's dive directly into the challenges. In recent years, application development, I mentioned that, really undergone a major transition. Applications are shifting to cloud-native architectures, and this brings with it some risks and challenges. And according to analyst firm IDC, by 2023, a mind-boggling number of over 500 million apps are going to be developed using cloud-native approaches. We'll talk about what it means in a minute. CDN providers, CDNetworks, highlighted that in the first half of 2020, they saw web application attacks rise by 800%. And if you add to that the fact that, and this is quoted from Akamai, a CDN vendor, out of all the web traffic on the internet in 2020, I believe that was, 83% can be attributed to API calls, and that's for a reason, mainly for mobile applications, modern applications, and cloud-native web applications that interact using APIs, as we'll mention, and as we will see in the next slide. So next slide. Okay, so let's take a look at how previously or traditional web applications were developed and deployed. Up until today, the standard way for deploying a web application was using servers. These could be bare metal servers, could be virtual servers or VMs. The way you would deploy the web application, you would place, you would use a CDN vendor to offload all the static contents of your server, like images, cascading style sheets, JavaScript files, etc. Then you would place a web app firewall on the perimeter, maybe a load balancer to load balance between the different web servers, and some backend services like databases, message queues, etc. But that was mainly the way people would deploy. And that meant that you had a very easy perimeter. You can imagine like a circle around this entire block where you can place the web app firewall to inspect traffic going from what's referred to as north-south, from the internet to the public internet to your web servers. And as we adopt cloud-native applications, this traditional model change. And the way it changed is, first of all, application logic is now implemented not all in one place. It's not all on a single web server, but rather as very distributed microservices, where each microservice is deployed probably as a container inside the cluster. This cluster is usually orchestrated by a platform like Kubernetes or something similar. And then you would have all sorts of backend services. Some are implemented using your own databases. Some can be in-house built, and some are based on public cloud services like cloud databases, storage buckets, cloud message queues, and so forth. In addition, some of the logic, it's not really appearing here, but can also be implemented as ephemeral serverless functions, where you instantiate a function to do some job, and then the function essentially dies after execution. So there's really no kind of hardware related to you. Obviously, the cloud provider is running the hardware for you. So what's really unique about this model? So the first thing is that this model can be broken down and run in multiple places, locations. It could run in private cloud. It could run in public cloud. It could run both. You can have certain components of this architecture running inside a private data center or private cloud, and you can have some services, backend services, databases, serverless functions, or containers running on the public cloud. So we have what's referred to either a multi-cloud scenario or a hybrid on-prem and cloud deployment. The second thing that is important to note is that the application can now automatically scale to meet the growing and shrinking demands. So things like the Kubernetes cluster that you're seeing here can grow and scale depending on the amount of work or amount of requests that you have to run tasks for. And this means that you don't necessarily know the amount of instances, or for this matter, where they are actually running. And that is obviously both challenging, but also very rewarding. Another thing to note is that the microservices inside your microservice architecture communicate with each other internally, what's referred to as east-west traffic, using API calls. And these API calls can be RESTful APIs, you probably heard that term, or GraphQL, the more modern way to send API calls, or even gRPC, which is a binary format developed by Google. Last but not least, you will notice that the boundaries are slightly different here. In this case, there really are no boundaries. There's no perimeter. There's no perimeter where we can deploy a web application firewall. So where do you put it? You put it in front of the application, but then what happens to things that are running on a different cloud? What happens if the payloads that the workloads that you have are serverless functions? Where do you deploy the web app firewall? What happens if data coming into your application is not necessarily always coming from the person sitting in front of the CDN, but rather One action causes the container cluster to load the data from an S3 bucket. We know that web app firewalls don't really inspect data coming from S3 buckets. So there are many different ways to send input or consume input from and to this application. So the legacy way, the architectural model of placing a web app firewall on the perimeter doesn't really meet the security requirements of these modern cloud native web application firewall. Pardon me. Next slide. So here is a slightly naive table, but it helps to convey the message. If you look at the three main models of web app firewalls, we have the traditional web app firewall, things like that derive in the format of an appliance or a virtual appliance. Then you have the cloud-based web app firewall, mostly from CDN vendors, where the web app firewall is deployed on the edge. In the cloud, essentially you route traffic through it using DNS. And last but not least, we have the RASP model, the runtime application self-protection, which is essentially embedding an agent that instruments the application and sends hooks into the application code and monitors the behavior of the application and its input. So let's look at these three models and see where they have drawbacks or where they fall short in protecting modern cloud native applications. So first of all, we need a solution that we can deploy it in front of VMs that may be running in different locations, some on-premise, some in the cloud. These workloads can also run inside containers that can inflate and deflate and again, change location, or serverless functions, which don't really exist until you actually execute them. So deploying a traditional web app firewall might be good if you are running your application on premise, but it's slightly more difficult if you're running in the cloud. Especially if you're running in both locations, then you have to figure out how you deploy or where you deploy those web app firewalls. They also don't auto scale. So you need to do capacity planning. You need to plan ahead. You need to be able to deploy enough web app firewall instances to protect your cloud workloads, which shrink and expand as desired. If we're looking at east-west web traffic, so if you deploy your traditional or VM-based web app firewall inside your cluster between microservices, then it can definitely inspect this east-west web traffic. And so that's mostly what I can say right now about traditional web app firewalls. I think if we look at cloud web app firewalls, we see different types of drawbacks. For example, protecting VMs and containers or serverless functions, that's slightly different. What happens if you need to inspect traffic running east-west between your microservices? How do you do that? Do you route traffic out of your cluster back to the cloud WAF provider and then send it back? It doesn't make a lot of sense, not from performance perspective, as well as from a privacy perspective. You're sending potentially sensitive data out of your cluster and then back. A cloud WAF can definitely auto scale as needed if your cloud WAF provider has enough capacity. The main problem with this model is that you cannot deploy it to protect private or private clouds or data centers or on-premise for that matter. The RASP model is unique in the sense that because it is located as close as possible to the workload itself, it can inspect east-west web traffic, and it can auto-scale with the application and supports, essentially running anywhere. But the ability to deploy it in all of those form factors, the modern form factors that we discussed, VMs, containers, serverless functions, that becomes a problem because you have to start maintaining a ton of agents for the different containers and the different VMs. Where do you even place the RASP agent when you're running?
All right, I apologize. It appears we may have lost Ori.
Yeah, I can definitely pick it up. Can you hear me?
Yeah, I can hear you.
Okay. So Ori was mentioning all the, pros and cons of the existing solutions, but none of them really provide a holistic approach. And often what happens is that customers find themselves um, in a plethora of point solutions in those cloud native environments. Each of them is trying to tackle a different problem. Some of them are trying to solve the security problem. Some of them are considering stuff like DLP, scanning, segmentations, and that plethora of point solutions is really a pain point, because now you are trying to manage your security posture across various products, various dashboards, and trying to integrate all of them into a single solution. And really, today CISOs are expected to deploy all sorts of categories. Like we have like 15 or more different product categories that are listed in here, and they have to know these categories, understand the needs and requirements, and deploy different products and learn how to use them and how to integrate them. And that's a really pain point. So an ideal approach would have integrated all of these solutions into a single product. And I think that this is where our approach to securing cloud native web apps becomes really unique. So WAS, our web application and API security product, is part of a comprehensive cloud native security platform. And all these areas that you're currently seeing are made better through integration, and they really differentiate us in the wider market. So WAS is part of the cloud workload protection solution. That's the middle pillar that is protecting containers, hosts, and serverless functions. And I think that this is where WAS really shines. And Ori mentioned all those pain points, the complexity of deploying in cloud native solutions where you have a mix of containers, hosts, serverless functions. How do you position the firewall? How you gain visibility into all that east-west traffic? Scale up, and how do you deal with all those point solutions? And this is where WAS really shines and why customers prefer us over the competition. So by using Prisma Cloud Compute Defenders, user can protect applications even in the most complex deployment scenarios. We have defenders for containers, for hosts, and serverless functions. Now, those defenders are part of the deployment, and this allows WAS to be deployed close to the protected application with full visibility into east-west traffic, as well as traffic originating from sources external to the deployment. Now, WAS auto-scales by nature. For example, for Kubernetes deployments, we deploy as a daemon set. So as you grow the number of nodes in your cluster, we grow the number of defenders to tailor the protection to the application needs. And most importantly, users manage their security posture in a single workload protection solution, either on a full on-prem solution or as part of their cloud security posture management. Now, this means that users can benefit from a multi-layered protection, and this is also known as the defense at depth approach, and we will see that in the demo. So in a single security product, you have WAS inspecting all of the incoming and outgoing HTTP traffic. You have runtime protection that is learning and profiling behavior of your applications and acts on any anomalies or deviations from it. Now, mind you, runtime is an additional strong compensating control. So even if some payload went through undetected by WAS, it might be either due to a 0-day or a never before seen evasion. Whenever that payload tries to execute, and if it's injected in the right context and the application tries to render it and run some arbitrary code, runtime would act on any unexpected processes that this code might try to spawn, DNS calls, or any weird behavior of the file system. So that's a second line of defense to the traffic inspection solution. And on a third line of defense, you have the vulnerabilities and compliance checks, and those are a preventive control that really shifts your security to the left, making sure that vulnerable images are not permitted to deploy and run in your production environments to begin with if they include high or critical vulnerabilities. So as I mentioned, our web application and API security, which we abbreviate as WAAS, is part of Prisma Cloud's workload protection. We call that Prisma Cloud Compute. And it provides the following protection capabilities via Layer 7 traffic inspection. So we have an app firewall that through app firewalling would protect against all of the OWASP top 10 threats, such as the code injections, command injections, XSS, SQL injections, etc. Now, in addition to that, WAAS is also able to protect customers' API endpoints. First, by automatically detecting them and profiling the traffic that is designated to them. WAAS inspects the traffic and learns the traffic to those endpoints. So it automatically discovers them, and then it's able to enforce the expected behaviors, such as the allowed HTTP methods, the required parameters, the parameter types, and etc. Now, WAAS is also able to protect against malicious bots and provide visibility into good known bots. Another layer of protection is the DOS protection. WAAS provides advanced DOS protection by limiting the rate of HTTP requests. And through custom rules, users are also able to create their own custom rules matching against incoming requests or outgoing responses to provide visibility and protection for customer-specific threats. Now, Palo Alto's Unit 42 security researchers are also able to provide users with virtual patches for all sorts of emerging and upcoming threats. Now, finally, for ongoing monitoring, we have developed a built-in advanced analytic that was specifically designed for efficient investigations of events and ongoing monitoring. So this is a quick overview of our web application and API security solution, WAAS in short terms. It's automated, so it easily discovers, auto-discovers, and protect all web applications and APIs on any cloud-native architecture in your private cloud, public cloud, or hybrid of both. It is integrated, seamlessly integrated with the industry's leading cloud-native application protection platform, that's Prisma Cloud, which protects the application across the application lifecycle. It's comprehensive with full coverage of the OWASP top 10, the advanced dot threats, bad bots, API attacks, malicious file uploads, and much more. And finally, it's best in class. So you can confidently protect web applications and APIs through that defense at depth approach with visibility, vulnerability detection, security posture management, and runtime protection. So going back to that comparison of our solution versus the competitors, you can see that not only do we take the modern approach for securing web applications and APIs, but rather we solve problems with a holistic approach and holistic solutions, unlike other legacy solutions. So to demonstrate the power of platform and how easy it is to set up WAAS, let's move into a hands-on demo. So this is my Prisma Cloud Compute environment. And my demo environment has an e-commerce application, which is a good representation of most modern cloud-native based web applications. Now, as you're looking at the radar view, you may have noticed that certain images have a crossed out red application firewall next to them. WAAS uses our Defender's visibility to inspect images, packages, expose ports, and runtime behavior in containers and hosts to determine whether they are running a web application. So next, WAAS would mark the applications and APIs that are currently unprotected with that crossed out red application firewall, and the protected ones with a green one. So you can see an unprotected web application detected right here. Now, take note of the large HTTP attack surface, as you can see. About 80% of my deployment is comprised of microservices that communicate over HTTP. And it is typically the case in the production environments of our customers. A cloud-native microservice architecture relies heavily on HTTP APIs. You should also note that if I was to deploy my protection, my firewall protections only on the front end, on the ingress or in the cloud, I would completely ignore this entire attack surface of east-west traffic. Those microservices are communicating among themselves, and every single incoming request would spawn dozens of backend requests between those APIs. So an exposed service can be used to attack other services without having the malicious message leave the perimeter or the deployment. So in cloud-native environments, the east-west traffic mirroring and monitoring, is critical for the security of web applications and API. So now let's click on one of the unprotected images I have in here and click on defend and see how easy it is to deploy a WAS rule to protect that Acme Shop Fitness demo application. Now, in order to keep this demo focused, I created a WAS rule, the webinar demo, ahead of time. So let's just go ahead and enable that rule and inspect it. The first thing we can see is the rule scope, and in the rule scope, you can see the webinar demo collections. Now, collection is a way for us to group containers and hosts in a deployment. And in my specific collection, this rule would apply to all containers that run in my demo cluster under the Acme Shop namespace. You can see that in here with an image name that contains the string Acme Shop in it. So in a very easy way, I'm able to match on multiple containers using my own deployment's metadata, and I can see all of these images and containers and the nodes that they run on. Next, we are going to look at the API definition. And in my protection policy, the first thing I'm noting is the protected endpoint. Now, every web application consists of HTTP endpoints, which is essentially a combination of HTTP hostname, ports, and base path. And in the app definitions, users specify the application endpoints they'd like to protect. Now, note the API endpoint discovery toggle, which is on by default. Now, this feature allows for automatic discovery of all API endpoints in those protected endpoints through traffic observation. I will now proceed to the app firewall tab, and in the app firewall tab, users can enable various OWASP top 10 related protection, all the code injections, XSS. You can see the categories in here, and the protections can be set with one of three actions: alert, prevent, and ban. Now, if need be, those protections can be tailored to the application need through excluding certain path, locations, parameters, etc. Under the DOS protection, users can set the acceptable rate thresholds of average requests per second going to the protected endpoints. And any attacker who would exceed these rates would trigger either an alert or the ban action. There are some additional advanced settings that you can apply, such as a rate threshold only for HTTP requests that meet certain match criteria through this DOS protection. Under access control, users can have the ability to restrict access to the protected endpoints, either based on IP addresses and network lists or via geo-based locations. They can do so based on HTTP headers, and they can also restrict file uploads, only allow certain file extensions to fend off malicious file uploads. Now, in the bot protection, users can manage three types of bots: the known good bots, unknown bots, and user-defined bots. And in the known bots, we have all the bots that are classified by their intent and nature. For example, search engine crawlers, SEO ranking bots, site monitoring tools, etc. And as part of the unknown bots, we flag requests originating from any automation that WAS cannot classify. Those could be command line tools, web scrapers, headless browsers, bots impersonating users, human users, or impersonating other bots, and all sorts of other automations. I will mention that a variety of bot detection methods is available within our bot protection, starting from passive inspection of HTTP requests to more advanced methods such as JavaScript injection for fingerprinting, session validation, and reCAPTCHA challenges. Now, in the custom rules, as I mentioned, this is where users can create their own custom rules, matching either on incoming requests or outgoing responses with whatever detection logic that is relevant to their threats. it will provide both visibility and protection against customer-specific threats. For example, you can have a customer that is creating a DLP rule that inspects server outgoing responses for leaks of sensitive information and PII disclosure. Now, as part of our custom rules, Palo Alto security researchers at Unit 42 can also provide users with virtual patches for new emerging attacks and threats. A good example for that are the virtual patches that were recently provided to protect against the Log4Shell vulnerability. You can see them in here, and we will shortly see a demonstration of the virtual patches in action. So let me save the rule and go back into my radar view. And as you can see, all these images running those web applications and HTTP APIs are now marked with a green firewall, and they are protected. And clearly, setting up WAS protection, even in the most complex environments, should take no more than 5 minutes. Next, let's head into the API observation section. I'm going to go into Monitor WAS. By the way, this is our dashboard showing you your security posture, attacked entities, where traffic is coming from, etc. But I'm going to head into my API observations. Now, in this section, as I interact with the application, a model is being created of all my API endpoints, the HTTP methods that they are accessed with, and the message field. So if I'll click on the login, I can see the structure of the login messages. And if I'll go into the add to orders, I can see all the parameters within that. And all these definitions can easily be exported as an open API definition file and be imported back, used in our protection policies to enforce the expected behavior. So next, let's see the power of the platform in action using the infamous recent Log4j vulnerability. So I'm going to switch back into my radar view, move out of my cluster, and go into my non-cluster containers, where I have the image of my Log4j vulnerable application. Clicking on the image, you can immediately see that our defenders have analyzed all the layers within the image, the exposed ports, all the packages that are used, the vulnerabilities, in which at the top of them you have the Log4j critical vulnerability. But we also created a runtime model learning all the processes and networking call of this particular container. Now, I will exploit this application. I will set up an LDAP server and a reverse shell. But before I do so, I'd like to first set all the Prisma Cloud protections on alert, so we can see how the Prisma's defense at depth approach copes with a real-world threat, and how each of these protections layer on its own could have prevented this exploit. So let's review the existing protections I have in place. If I'll go to defend vulnerabilities, I have a policy for containers with critical vulnerabilities. And again, it's currently only set for alert. So this policy would alert on any containers with critical vulnerabilities in them. In runtime, I have a runtime policy that is based on the learned model of this application. So the processes that were learned are allowed, and everything else is currently on alert. If I'll see malware, cryptojackers, everything else is here on alert, and same goes for networking code. I know that this port should be exposed, and everything else currently is on alert. And last but not least, we've seen the Log4j policy, where I have my virtual patches for Log4Shell set on alert. So now let's go over into my terminal and see what I have in here. On the left side, I have the vulnerable Log4j application. It's a Spring Boot application. On the right side, I have my attacker's machine, and I'm going to do several things. First, I'm going to set up a listening LDAP server. Next, I will set up a listener for my reverse shell. And now I'm going to send a curl command with the JNDI LDAP payload in an HTTP header. Now, as I send that command, you can see here in the logs that my vulnerable application is getting exploited. My LDAP server on the attacker machine is getting that command, the bash -c, and you can see all of that. And here in my reverse shell listener, I'm getting a shell. So I can do like, who am I? PWD, or cat/etc/passwd. I have a full shell into that exploited machine. Now, I remind you that this attack was allowed to execute with all our layers of defense on alert, so that they can observe how it was, so we can observe how it was reflected in each protection layer over time. So let's switch back into the console, into the containers, and we can immediately see that now this vulnerable web application has an aura all above it saying that this image has been involved in an incident. And if I'll click on that incident, I have a reverse shell incident with all the explanations and with a live forensic view of everything that happened since this container has started. So we can see the timeline, and we can see that the container was started right here. The ports were open, and as I scroll up, I can see an outbound connection to a bean bash on an unexpected port. I can see the reverse shell identified when the bean bash process is spawned. And from that point on, you can see all of my commands, the who am I, cat/etc/passwd, all of that is in here. And if I'll go into my event monitor right here, and I'm on the WAAS for containers part, and I'll just filter on the log4j image, you can see the alerts that have been generated by WAAS that identify the curl command that I sent. You can see it in its raw form with the JNDI LDAP payload in the HTTP header. Awesome. Now what I would like to do is do kind of a reverse process. Let's see how each of these protection layers could have prevented this. So first I'm going to go into my WAAS policy in my layer 7 traffic inspection policy and set those virtual patches to prevent. I'm going to go back into my terminal and try to send that curl command. Now I'm getting a 403 forbidding. So the request is not allowed to reach the protected application. Nothing happens in here. You don't see anything in the logs. The request does not go through. This is the first line of protection. You have WAAS doing traffic inspection and looking at all of the incoming traffic. So let's go back to WAAS and set the policy here back to alert. And I'm going to go into runtime and now switch my policy to prevent. Let's go back in here. Let me restart that. Set up my reverse shell listener. There you go. And try to send the command. Now, I remind you, WAAS is on alert, so the request is allowed to go through, and you can see in the log that the application is actually trying to get exploited, but this time I'm not getting any shell on my listener. So the command is going through into the LDAP server, but runtime protection prevents the bean bash process, the command, the process to run the command tools from being executed. So I'm not getting any shell at all. So this is the second line of defense. WAAS inspecting incoming traffic and runtime that would block anything that is deviating from the application's normal behavior. And lastly, I can go into my vulnerability policy and now block any workload from running if it has a certain threshold of vulnerability severity. And I'm going to set that to critical. If I'll go back into my terminal, let me terminate that application and try to run that application, vulnerable application again. This time I'm getting an error response from the daemon saying the operation is blocked by policy. This is the policy for containers with critical vulnerabilities. So as we have seen, Prisma Cloud Compute defense at depth approach can easily mitigate a severe real-world attack with confidence. And this is not just due to the fact that each protection layer could prevent the exploitation on its own, but rather the combination of all three together provides a robust solution that is easy to configure. It runs across the entire stack and is fully automated. You have WAAS monitoring all incoming and outgoing HTTP traffic. You have runtime that learns the behavior of the application, of each application, and reacts when any anomalies occur. And you have the vulnerabilities and compliance checks that keeps all workloads aligned with your risk appetite, preventing them from being deployed if they do not comply with that. Let me switch back into the presentation. And before we move next to the Q&A section, I just want to mention that if you find this interesting and want to learn more, there are several ways that you can get in touch with us. The deck would be shared with everyone on this meeting, so you will have all these links. You can request a free trial for a Prisma Cloud and WAAS. You can schedule a cloud native security bootcamp, or take a virtual ultimate test drive with the product, or just ping one of our Prisma Cloud specialists for every questions or inquiries you might have. And now we're in the Q&A section.
All right, so it looks like we've had a few questions come in so far, and for anybody who has any questions still, feel free to pop them into the questions panel. So the first question is, how can I deploy web application and API security?
So deploying WAAS is very easy. For existing Prisma Cloud Compute users, all they have to do is go into the console and just create a WAAS rule. And as I've just displayed in the demo, creating a WAAS rule should take no more than 5 minutes. Select the type of workload you'd like to protect, container, host, app embedded, or serverless, and create a rule, and within a couple of minutes, you're good to go with all the protections in place, observations, and everything else that I've discussed about.
All right, the next question I see is, do I need to maintain or keep the solution like a legacy WAF?
So WAAS can definitely replace with confidence any legacy WAF solution you have, and probably provide you a more holistic solutions as you've just witnessed in the demo, with not only traffic inspection, bot inspection, API protection, but also with advanced discovery mechanisms, with our radar view analytics, runtime, and vulnerabilities. So you get a full holistic view of your application, not just traffic inspection.
All right, next person is asking, can I customize where the alerts are sent to?
Well, definitely. There are various ways you can ingest alerts and WAAS audits. You can consume them through syslog messages, or you can use our alerting system that has a lot of integrations with various providers, as you can see in here, and can be highly customizable to your needs. So you have webhooks, Jira, Splunk, our own Cortex, and essentially a lot of integrations in here. Any other questions?
Yeah, so I just found another one. It says, the log4j example was known now, but what about the vulnerabilities which are yet not known to us, and how to set up rules for such cases? Also, does Prisma run discovery until all open source components are being used in the running app or app container?
Yeah, so I think that in essence, runtime protection is one of the best, again, compensating controls for all those 0 days up there, because at the end of the day, assuming that we have a 0 day, something that we did not discover, and a payload gets injected into the application. And as all of you know, that's not enough. The payload has to be injected in the right context, and everything has to fall in place. But whenever that payload would try to run, he would try to behave in a way that is not typical to the application. It might be a loader trying to fetch something from an unknown or some networking address that the application never tried to approach. it may be, as we've seen, somebody trying to set up a reverse shell and run shell command and spawn processes that are not typically running within that container or host. Or it can even be a crypto miner or you know, someone trying to encrypt your file system or cause it to behave in a manner that the application never does. So I think that's a good line of defense. In addition to all the signatures and detections we have as part of the traffic anomalies, where again, these payloads would often contain all sorts of and shreds of commands or anomalies that are usually detected by our first layer of protection, which is WAAS, through the layer 7 inspection as well. And can you please repeat the second part of the question?
Yeah, so they were saying, does Prisma run discovery and tell what all open source components are being used in running the app or app container?
Yeah, so we run discovery on every component that is used within a workload, be that a container or a host. We also have some more, I should say, shift left capabilities, such as repository scanning, and some more infrastructure as code scanning. So you can go as left as you can, and we are scanning every package that is being used within a workload.
All right, we have another question here. What has to be done when the application itself changes and new capabilities are added and existing traffic patterns change by design?
So there are two modes of operation to the learning model of runtime protection. There's an automatic and learning mode and a manual learning mode. So you can either set a manual learning mode for a static period of time if you do not expect such changes to the application, or you can have an automatic ongoing learning mode that would try to decide on its own which patterns are malicious and which are benign. I would also mention that within runtimes, we have all sorts of anti-malware protections. We are able to have integrations with Palo Alto's Wildfire that can send binaries for detonations and verdict. You are able to block a container from running if suddenly a binary appears within that container that is not part of the image that this container was running. So all sorts of protections to make sure that on-the-fly changes are reflected in runtime protection as well.
Another attendee is asking, when we define and we design our API, is it possible to apply any pattern to secure our application?
I'm trying to think if you're alluding to coding best practices, and obviously there are a bunch of theirs with OWASP top 10 API security as well. But if you have the design of your API through a definition file, be that a Swagger or an Open API version 3 definition file, you're able to provide it to WAS, and WAS would make sure to enforce whatever contracts and definitions you've set and make sure that any request that does not comply with them either generate an alert or gets blocked or even bans the attacker from any further communication with the protected endpoints.
All right, so we have another question here. How do you auto-discover APIs in the environment?
So as I mentioned, WAS operates off of Prisma Cloud's compute agents. We call them defenders. Now, those defenders have visibility into the workloads they're running each. And I think I've showed that as part of the demo. You can choose, let me just go back into the console and just show that to you live. So you can choose any container, and what our agents would do, and that could be a host as well, they would look at the image and of the runtime environment of that workload, and they have full visibility into the layers within the Docker file. What are the packages that are getting dragged in, the exposed ports? They are parsing that out. And through that knowledge of the exposed ports and whether or not we have an HTTP server essentially listening behind them, we are able to flag those exposed ports. And if they are not protected, we will flag them. And that also comes in handy in both cases. First, as you can see, you have a visual representation of your attack surface within your deployment. You can also consume that as a report. But second, and that's the case in a lot of big customers with very dynamic environments, you have development teams constantly changing those images and doing all these rapid agile development. So if at some point a container that did not have any exposed attack surface, suddenly a new port getting exposed, and that port has an HTTP server listening behind it, then you would get that added into your unprotected web app report as well. So that's a general overview of how we detect those exposed ports in unprotected web apps.
All right, someone wants to know, how can WAF service be used in existing cloud services like AWS and Azure?
So as I mentioned, you can deploy our defenders in any environment. You can deploy them, and essentially the console would abstract everything away from you. So if you look at my demo console right here, if I'm not mistaken, and we'll go to the host, you would see some EC2 machines from Amazon and some from GCP. It doesn't really matter. As long as you have a defender at each part of your deployment, and it could be some on-prem, on a cloud, on a private cloud, on one cloud provider, or on 4 of these, those agents, those defender would report back into a single console, and all of that would get abstracted away into a single view of all your applications, regardless of where they are running. And those could be, containers, hosts, serverless functions, any manifestations of those services, and wherever they are located.
All right, so the next question is, can you generate reports on the protected web apps and APIs?
Yes, so all these, the reports on those can be consumed as reports. If you will go into the monitor section and look at the unprotected web apps, you can get a full listing of all the images and the ports they have, and you can consume that as a report, definitely yes.
All right, well, it looks like that was our final question.
Thank you very much. As I mentioned, use any one of these links that would be part of the deck that we will be handing over to get in touch with us. Any question you might have, you can ping me directly on myself or Ori on LinkedIn or however you can find us, or talk to one of our representatives and we can continue this conversation and address any questions or concerns you might have.
All right, well, with that, DZone would like to thank Ori and Olad for a great presentation. And DZone would also like to thank Palo Alto for providing the audience with a wonderful webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.
Thank you very much.
Thank you.